Hello and welcome to Geometry, Trigonometry Basics. In this video, we will solve problems using the trigonometric ratios and inverse trigonometric ratios for acute triangles. That means we're going to be using trig ratios and their inverses to find angle measures, find side lengths, and solve problems involving angle of elevation and depression. Here are some of the standards that we're going to be covering in this video. These are from the Florida's Best Standards for Mathematics. So let's go ahead and get started. In geometry, we are going to be using our three basic trig ratios: sine, cosine, and tangent. In later maths, you'll be learning more about like cosecant, secant, and cotangent, but for now we're just going to stick with the basics. So on your reference sheet for your EOC in Florida, you have the trig ratios written for you, so you don't necessarily need to remember them. A lot of people remember them using TOA, and that just helps with reminding you of how to write out those ratios, but they are already given to you. So let's go ahead and get started. So with this first triangle, the very first thing we want to do is make sure that we mark our hypotenuse. And then from here, they're talking about a specific angle. So for this triangle, we have theta. And then when we're looking at angle theta, we're going to go across, and that is going to be our opposite side from that angle. And then the other leg that is next to theta, or helps form theta, that is going to be your adjacent side. And remember, opposite means across from, and then adjacent means next to. And then, so for the sine of theta, it's going to be opposite over hypotenuse. So the opposite side from theta is B, and then the hypotenuse is C. For cosine of theta, it has the adjacent side over the hypotenuse. So the adjacent side is A, and the hypotenuse is still going to be C. And for the tangent of theta, we have the opposite side B over the adjacent side A. And so that is how you would write your trig ratios. And now let's look at if we were looking at our other angle. So now we're looking at angle sigma, and so we still want to label our hypotenuse. But then when we're looking at angle sigma and we're looking at the opposite side, that becomes A. And then the adjacent side to sigma is going to be B, the adjacent. So for the sine of sigma, sine sigma is opposite over hypotenuse. So that's going to be side A over side C. And then for cosine of sigma, we have the adjacent side, which is B over the hypotenuse C. And for tangent, it's going to be opposite over adjacent. And if you didn't know, sometimes they use Greek letters to kind of mark up these triangles, and so this is called theta. And then we've got sigma here. But sometimes you'll see beta, and so it just kind of depends, but that's not super duper important. So now let's do some practice. So we know that this is always going to be the hypotenuse. Your hypotenuse is always going to be across from your 90-degree angle. And then from here, it's really just knowing what those sides are in relation to that specific angle. So for sine R, if we're looking at angle R here, and we're trying to find the sine, we need to know the opposite side is going to be 16. And so we've got 16 over the hypotenuse 34. Our cosine is going to be our adjacent side. And so that's going to be 30 over 34. And then for our tangent, it's going to be our opposite over the adjacent, so 16 over 30. And then you don't want to forget that you want to simplify these. So we can pull out our calculator, make sure it's all cleared out, and we have 16 divided by 34. And then we're going to do second f to d, and that gives us 8 over 17. And then you want to do that same thing for the others as well. So now we've got 30 divided by 34 equals second f to d, 15 over 17. And our last one, we have 16 divided by 30. And we have 8 over 15. Okay, all right, now let's try with the sine of S. And so now we're talking about angle S. The hypotenuse is still going to be the same, but now our opposite side is now that 30. And our adjacent side is now 16. So the sine of S is going to be opposite over hypotenuse. And notice that it's just opposite of what this one is, right? So when I'm looking at this, if we go back into our old one, we can see that these are kind of crisscrossed here. And then our tangents are just flipped for the other. Okay, and so I know that if I were to go through and do this, I know that the sine of S is going to be the same as the cosine of R. The sine of R is going to be the same as the cosine of S. And then for my tangent of S, I can just flip over. Sorry, I'll put the original. I can just flip over the tangent for R. And now I don't even have to do all the extra work because I've already done it. So this is going to be 15 over 17, 8 over 17, and then this one is going to be 15 over 8. Now let's get into using trig ratios to find an angle measure. So what we're going to do is I still like to label my hypotenuse, and this is talking about angle A. So we're talking about in reference to angle A. So you can name this theta, or you can just kind of mark it. And so I'm going to mark angle A as my reference angle. And then I want to figure out what these are. So this is going to be my opposite side. And this is going to be my adjacent side. So based on what information they gave me the opposite side and the adjacent side. And then I want to figure out which trig ratio uses those two. So the one that uses the opposite and the adjacent is my tangent. So now I'm going to do tangent of angle A is equal to opposite over adjacent. So that's going to be 8 over 14. And then just like how we do division to get rid of multiplication, the opposite of addition is subtraction. The opposite for this one is where we're going to do the inverse tangent and that is going to get rid of the tangent part. And so we're going to do that on both sides. Okay, and so the inverse tangent cancels out my tangent part to where I'm just left with angle A, and then I'm going to put this into my calculator. So I want to make sure everything is cleared out. And then when we're looking at our calculator, you can see sine, cosine, and tangent. And then right above it, you have the inverse sine, inverse cosine, and inverse tangent. So now I'm going to do 8 divided by 14. And then I'm going to do the inverse tangent. And that gives me 29.74. And then I'm just going to round it off there. So 29.74. And remember, with this calculator, you're kind of writing things backwards. When you use the blue TI-30XIIS calculator, you can just type it straightforward. Same thing with a graphing calculator. But with these, you have to type your fraction first, or your number first. So put 8 divided by 14 and then hit second tangent. All right, let's try it again with angle R. So now we're looking at angle R. And I want to always label my hypotenuse first. And then from there, I can figure out what my opposite and my adjacent are. So I have my adjacent here. And so now I have the adjacent side and my hypotenuse. I'm going to look at my trig ratios and figure out which one uses adjacent and hypotenuse. That's going to be cosine. And so now I can write out my formula. So now I've got, or my equation, I have cosine of angle R is equal to adjacent over hypotenuse. And then to get rid of the cosine part, I'm going to use the inverse cosine. So I have cosine, and then it's that little -1 there. That's not an exponent, that's just kind of telling you that it's the inverse, okay? And then we've got cosine of R, and then we're going to do inverse cosine of 7/18. This is going to cancel, and we're just going to be left with R. And then I'm going to put my fraction in my calculator. So I'm going to clear everything out. 7 divided by 18 equals. And then I'm going to go ahead and do second cosine, and that's going to be 67.11. And these are in degrees. Also make sure that you haven't bumped any of these settings on your calculator. This should say degrees on your calculator. If it says radians, you need to change it. So make sure that it says degrees on your calculator. So make sure that's set to the correct setting. All right, now let's move into using trig ratios to find a side length. And so this is very similar in how we kind of approach the problem. So this one is telling us that we're looking at angle Z. That's the one that they gave us. Now, it doesn't matter if you used angle W. So if I were to go through and figure out what W is using my triangle sum, and then use W, it would still work the same. It's still going to come out to the same thing. But they already gave us z, so we're just going to stick with that. So I label my hypotenuse. I always label my hypotenuse just so when you're starting out, you're not accidentally labeling your hypotenuse as an opposite or adjacent. All right, so now from here, they're asking us about xz. So this is the side that they're asking for. And so when I'm looking at this, that is going to be my adjacent side. And then they also gave me the hypotenuse. So now, instead of doing where I'm saying angle Z, I'm going to actually use 57. So now I have the adjacent and the hypotenuse. That's going to be cosine. So now I'm going to say cosine, instead of Z, I'm going to actually put 57. Equals, and then the adjacent side, which is xz, that can become x or whatever letter you want to, so I'm just going to put x here, over my hypotenuse, which is 18. And now from here, I'm just going to use regular algebra to get rid of that. And so to get x by itself, I would have to multiply both sides by 18. And now I can put that into my calculator. When looking at the calculator, remember that the 57 has to go before you type in the cosine, because it's kind of backwards with these calculators. So I'm going to do 18 times 57, and then you hit your cosine. And then make sure you press equals at the end. So let me do it again. We've got 18 times 57 cosine equals, and then that gives us 9.8. So now from here, these 18s canceled out, and I was left with 9.8. And then if you had to round to the nearest hundredth, it would be 9.80. Okay. All right, now let's do the same thing and find XW. So for XW, that's this one, right? And so I'm just going to go ahead and label that as Y. So I know that XZ was my adjacent. If I go across, that's going to be my opposite. And so that is going to be using the sine trig ratio. And so I have the sine of 57, which is Z, equals the opposite, which is Y, over the hypotenuse, which is 18. And then I would do that same process with that one as well. And if I chose to go through and use 33 for this one, it would still come out to the same thing. So let's go ahead and do this one first. So this one has same process, right? Times 18. And then I know that these are going to cancel out. And so I get Y equals 18. So I'm going to pull this calculator back up. 18 times 57, and then we're using the sign for this one. Make sure you hit that equals at the end. And I get 15.10 if I had to round it, because that 6 would change the 9. So 15.10. And now let's kind of just look at if I were to use the other angle. So let's say I wanted to use 33 here. And so if I were to use 33, this would be, X would become my opposite, right? and then 18 would become my hypotenuse. And so I would have opposite and hypotenuse, that's sine. So sine of 33 would give me x over 18. And then I would do the same thing with this one. And when I plug this into my calculator, we have 18 times 33 sine equals, and I still get the same answer of 9.80. And so this goes back to what we talked about earlier when it came to our trig ratios, that the sine of theta was the same as the cosine of our other angle. The cosine of a theta was the same as the sine of the other angle. And so using that in our calculator, it proves that. Alrighty, let's try another example. So let's go ahead and start with HF. And so if I'm looking at 32, that's going to be my adjacent angle. Remember, this is always going to be our hypotenuse. And so with this, we have adjacent, our adjacent side over our opposite side. So with this one, that's going to be our tangent of 32. So tangent of 32 is going to be opposite, which is 11, over our adjacent, which is now going to just become x. And with this one, there's a shortcut with this to where you're not having to do a whole bunch of extra work. When you have x on the bottom like that, you can just switch those two. So this now becomes x equals 11 divided by tangent 32. And now we can put that into our calculator. So now with our calculator, we clear it out, and we're going to have 11 divided by 32 tangent equals, and that gives us 17.60. And I just want to remind you that if you're not feeling super comfortable about using your handheld calculator for these trig ratios, you can still use your on-screen calculator, which is the same as your Desmos scientific calculator. So if you're not feeling super confident using your handheld, just use the on-screen calculator. You still have both calculators at your disposal. And the Desmos calculator makes it a little bit more clear, and you can type it a little bit more as to how it looks on your paper when you're actually writing out your equations and all that good stuff. So you still have that option. All right, now let's switch over to GH, which is now our hypotenuse. So now we're looking for this side here, and so I'm just going to name that Y. And so now I have the opposite side and my hypotenuse, which is going to be my sine function. So now I have the sine of 32 equals opposite over hypotenuse. And then remember, we can use our shortcut with this. If our variable is on the bottom, we can just switch those. And so we have y equals 11 divided by sine 32. And then from here, we can just put that into our calculator. 11 divided by 32 sine equals, and that gives us 20.76. Okay, and then remember that these are side lengths, so if it's inches, you would put inches. If it's meters, you put meters. And then if you're doing angles, then it's, of course, degrees. All right, so this kind of question leads into the unit circle, which you'll see more of when you get into classes, especially like pre-cal. But with this one, it's just kind of giving you an introduction, and we're still using our regular trig ratios. So for this one, it says find theta based on the given point. And so I'm just going to go ahead and kind of sketch out a coordinate plane, and so this says negative 0.28, so I'm just going to imagine that I'm going negative 0.28, and then I'm going down to negative 0.96. And so now I'm going to create a triangle with my x-axis. And I put a little note down here at the bottom. Angle theta is made by using the hypotenuse and your x-axis. So now this becomes theta. Okay? And so when I'm thinking about how much I went down, right, I went 0.96. And then when I think about how much I went to the left, I went 0.28. And so that would be the distance. Make sure that you're not putting negatives on those distances, because we can't have a negative distance. It's just telling us what direction we went in. So we went to the left and then we went down. So now I have a right triangle. And here's theta, 0.28, and then 0.96, and then from here I can solve for theta. So now I have my hypotenuse, this is going to be my opposite, and my adjacent. And so which one uses opposite and adjacent? That's going to be our tan. So tangent theta equals opposite, which is 0.96, over adjacent, which is 0.28, and I could figure out what my angle is from there. So now, to get theta by itself, I'm going to do the inverse tangent, and so now I have inverse tangent, and then some people write inverse tangent on this side, and then these two cancel, and I'm left with theta equals, and then you write it properly when you go to show your work on this side, 0.96 over 0.28, and then I would just use my calculator. So now I have 0.96 divided by 0.28 equals, and then I'm going to do my inverse tangent. So remember, that's second tangent equals, and that's 73.7, and I'm just going to round to the nearest tenth. 73.7 degrees. And then I could also find my hypotenuse. I could have done Pythagorean Theorem to find my hypotenuse and then used sine or cosine. It really doesn't matter. But I just used the ones that they already gave me. Alright, so now let's get into some word problems. And so these are often going to be angle of elevation and angle of depression problems. And so you kind of want to sketch out a little picture. So this says Imani's kite, is flying above a field at the end of a 65-meter string. And then if the angle of elevation to the kite measures 70 degrees, how high is the kite above Imani's head? And so with this one, we can draw a little picture. Here she is, and she's flying a kite, right? And so the kite okay, and so it's 65 meters of string, and then we're creating a triangle here. And so they're asking how high is the kite above her head, and so they're asking for x here. And then the angle of elevation is always going to be from where her head is to as if she was looking straight forward and then going up. So your angle of elevation is going to be here. And they're telling us that the angle of elevation is 70. And so this becomes 70. And so now from this angle, x is our opposite, and then we know that this is our hypotenuse. And so which one uses opposite and hypotenuse? It's going to be sine 70 equals opposite over hypotenuse. And then from here, we know that we're going to multiply both sides by 65. And then we can put this into our calculator, turn it on, clear it out, 65 times, and then make sure you put 70 first, and then hit sine, and then equals. And so that's going to be 61. And then from here, when they're kind of saying like how high is the kite above her head, they mean like what is the height or the distance between here and there. And so 61 is still going to be on this side. And so I know it's a little hard to kind of conceptualize because you're thinking, well, the kite isn't right above her, but it's 61 feet or meters. Sorry, it's meters above her head. So that's going to be 61 meters. All right, let's use another one. It says a 14-foot ladder is used to scale a 13-foot wall. So we've got our wall here, and that's going to be 13 feet. And then we have a ladder here that is 14 feet. And then it says, at what angle of elevation must the ladder be situated? So angle of elevation, remember, is this bottom angle here. So we're going to call that theta. So now opposite and our hypotenuse. So we've got sine theta equals opposite over hypotenuse. And then remember with these, we use our inverse signs to get rid of the sine. So now we've got theta equals inverse sine 13 over 14. And remember, you don't have to put that fraction or that exponent in. It's already built in when you see this button here. So we've got 13 divided by 14, and then second sine, and that gives us 68.2. So theta is 68.2 degrees. And then if they asked us about any other parts of the triangle, how far is the base of the ladder to the wall, you could label this as X. If they asked us about, you know, what angle, we have it all. Okay. All right, so now let's go into our last problem. This is angle of depression. So this says from an airplane at an altitude of 1,200 meters, the angle of depression to a building on the ground measures 28 degrees. Find the distance from the plane to the building. So we've got a building, and then we've got a plane. And so with our plane, we've got a triangle here. Now, angle of depression, this is where a lot of people get confused. If we're looking at the plane and the plane is going straight, right? If we're talking about whether it's going straight and then we're looking at the angle in which it would go down towards the building, that is going to be your angle of depression. And so your angle of depression here is 28, but that's not necessarily what's inside your triangle. So when we're looking at our triangle, if this is 28, then we know that this piece here is going to be 62. And so 62 is what we're going to be using in our trig ratio. So now it says the altitude of the plane is going to be here. And so they're saying the altitude from that building to the plane, not necessarily from the plane to the ground. Either way, even if you took your triangle all the way down to the ground, it would still give you the same results. And so this angle is going to be 62. We've got 1,200. And then it says find the distance from the plane to the building. And so that's going to be this here. And so that is our hypotenuse. And this is our adjacent. Which one uses adjacent and hypotenuse? It's going to be cosine. So cosine 62 equals adjacent over hypotenuse. And then, of course, we're going to use our shortcut. And so I get x equals 1,200 divided by cosine 62. And so I'm going to plug that into my calculator. So 1,200 divided by 62 cosine equals, and that gives me 2,556.1. And that's going to be meters. And that concludes our video.